Hey guys, welcome back to part 12 of the SQLite quiz tutorial. So in this video we will make some more changes to our SQLiteOpenHelper class to prepare all the necessary queries, and in the next video we will then put everything together, so after that our categories feature should be working. But first of all I want to clarify why we put our categories in another table, because I didn't really make that clear in the last video. So as I already said, the reason why we put our questions into an SQLite database instead of just hard coding them into Java classes is to make it possible to add new questions later from within the app. And if the user has the possibility to add new questions later, he should also be able to add his own categories, because otherwise we would force him into the few categories we have prepared, and that would be really limiting. Instead, he should be able to add more categories, and for this we have to create another table because we have to store them somewhere. We didn't add another table for our difficulty levels, because I think it's okay if the user can just pick between the ones we have prepared, instead of adding new ones. And foreign key constraints are there to enforce the relationship between our questions and the categories, so we don't end up with orphaned or invalid entries. So we go back into Android Studio, where we are still in our QuizDB helper class, and let's go below our addQuestion method. Here we add another method, which is public, and returns a list of type category, and we call it getAllCategories. No arguments. And as the name implies, here we want to return all the categories from our database, and this is pretty similar to our getAllQuestions method. Here we create a new list, again of type category, which we call categoryList, and we initialize it as a new array list. Then the same as in getAllQuestions, we assign db to getReadableDatabase and create a cursor z db.rawQuery, where we pass select asterisk from space plus categories table name and null for the selectionArgs, because we want to return all categories. Then we want to recreate category Java objects from these entries. So we write if c.move to first, curly braces, do, we create a new category object, and then we have to read the ID and the name out of the database and set it to this category. So category.setID, c.getInt, c.getColumnIndex, categories table dot underscore ID, and in the next line category dot set name, c.getString, c.getColumnIndex, categories table dot column name. Then we want to add this category to our category list dot add category semicolon. Here where this red line is, we write while c.move to next. This is nothing new, we already did this when we read our questions out of the database. Outside of the if statement we close our cursor and return this category list. So this method just reads all categories out of our database and returns them as a list. We don't have to make changes to getAllQuestions, because we still want this to return all questions, but we have to change getQuestions. Because here at the moment we only filter for the difficulty level, but now we also want to filter for the category additionally. So before string difficulty, we also have to pass an int category ID and add this to our query, so later we only retrieve the questions that fit to both the difficulty level and the category. For this we only have to make some changes to our query here. So let's just delete it and recreate it. First we create a string selection, which will contain the query itself, but without the where keyword. So we write questions table dot column category ID plus, then we add a string, space equals, space question mark, space, outside of the string we append plus, another string, space, and space, plus, questions table dot column difficulty, plus, and then we append the same string as above, equals question mark, and then we close it with a semicolon. We want to filter for the category ID and for the difficulty level. And we will replace these two question marks with SelectionArgs. So we create a string array, we call it SelectionArgs equals new string array, and then we add curly braces, and here we have to pass the category ID and the difficulty level in the same order as we use them here. So first the category ID, then the difficulty level. And they both have to be strings, so we can't just pass the category as an integer. Instead we write string with capital S dot value of, and in here we pass our category ID. This will turn this number into a string, comma, and a difficulty, which already is a string. And then we create a cursor, db dot, and so far we always used rawQuery. But this query is a little bit more complex, so we will use the query method here, where we have to pass each part of the query separately. And this is easier to use for more complicated queries. First we have to pass the name of the table we want to query, which is our questions table, because we want to retrieve questions. Questions table.table name, comma, then we have to pass the columns we want to return. We want to return all columns, so we can just pass null, which will not apply a filter. Then we pass our selection string, comma, and we didn't add the where keyword to the string because we don't need it for this query method. Then we pass the SelectionArgs, comma, and then we pass null 3 more times, like this, and close it with a semicolon. And from these words here you can see what these keywords stand for. We don't want to order it, and we don't want to group it. Okay, we don't have to make any changes to the way we retrieve our questions, because just the query changed. And then we want to make one more change to our QuizDBHelper class. We want to turn it into a singleton. For this we scroll all the way up. So far we only used our QuizDBHelper class in our quiz activity. But now that we want to add the spinner with the categories to our starting screen, we also need to access our database there. And if we initialize our SQLiteOpenHelper multiple times from different activities, we actually open multiple database connections, which is a memory leak. And to avoid this, we can simply turn this class into a singleton, which means that we will always only have one instance of our QuizDBHelper. This is pretty simple. For this we create another member variable. It's private static instance of our QuizDBHelper, which we call instance. Then important, we make our QuizDBHelper constructor private, because we don't want to be able to create new objects of it. Instead we always want to return the same one. So below the constructor, we create a public static synchronized method, which returns a QuizDBHelper instance, and we call it getInstance. Synchronized is there if we want to access this QuizDBHelper from multiple threads, and static because we have to access this method without creating a QuizDBHelper object first. And we have to pass an argument, which is a context. And then we check if instance is equal to null. Only in this case we have to create a new instance. So we write instance equals new QuizDBHelper, and then we pass context.getApplicationContext, because we want to use this QuizDBHelper in the context of our whole application and not just for the lifecycle of one single activity. And outside of this if statement we return our instance variable. So if we already have an instance of QuizDBHelper, this will not be initialized again, and instead just return the existing one. And then later we will not call new QuizDBHelper, instead we will call QuizDBHelper.getInstance. But you will see this in the next video. So make sure to subscribe to the channel to not miss that, and if this video is helpful, please leave a like. Take care.